Hey everybody, thanks for joining us. Excited to talk to you about Kubernetes, logging, DevOps, all those wonderful words. Excited to have Lee with us. So to introduce myself, my name is Dan Garfield. I'm the, among other things, Chief Evangelist for Codefresh. If you haven't heard of Codefresh before, some of our customers include companies like Giphy and Citrix, ARM, Figaro, and we've built over 3.5 million images. Those are Docker images. So very excited to be presenting today about Kubernetes and DevOps, and glad we can have Lee with us to bring all of his expertise on logging. So Lee, why don't you introduce yourself?
Yeah. Hello, everyone. My name is Lee Liu. I'm the CTO and co-founder of LogDNA. LogDNA has been growing really rapidly recently. We have now over 2,000 customers who have been with us. Been really awesome so far. Hope to see and introduce a lot of you to LogDNA today.
Great. So let's talk about what we're going to cover today.
Yeah, so a couple of points, just very high level. We want to keep this so that there's plenty of time for questions at the end, but this is the structure and the outline for today. We're going to go through each point, and yeah, we'll go ahead, we'll take it away.
So first, before we kind of jump into the how Kubernetes handles logging and how this fits in the kind of normal development and DevOps workflow, you have the problems of deploy, monitor, and fix. And this is kind of why we decided to partner up on this webinar and talk together, because Codefresh will help you with the deployment, will help you with issuing fixes, and LogDNA has a great solution for monitoring. And so this is kind of a cycle you go through where you deploy something, you monitor it, you find issues, you fix it, you deploy it again, you monitor it, and so on and so forth. So that's kind of the high level of where this all fits in together. And so let's just jump into kind of the why logging is important.
Yeah, so logging, as many of you know, is a really good tool for troubleshooting different things into your apps. We use it ourselves. It helps mainly to reduce a lot of the pain points of having a black box, which is how most applications that run today, you don't really know what your apps are doing. Logging basically helps you uncover some of the ticker tape, if you will, of how those things work. Beyond this, a lot of how logging, especially in the Kubernetes landscape, is you don't need to give all your developers access to kubectl or your production clusters. They can now use logging in a more controlled environment where different people can get different access, so that you don't have to set up crazy RBAC or any sort of permissions on Kubernetes to make that happen. So here's how most companies determine what their logging needs are. They can come from generally like a security compliance perspective. So for LogDNA, we are HIPAA compliant. We are also SOC 2 compliant. For HIPAA specifically, we will sign what's called a BAA. Basically, what that tells us is that we believe our product is so secure that should something happen and we get hacked, we are actually legally liable for it to take that on. So security is very important to us. So we also have a Privacy Shield that is sort of like the precursor to GDPR. We're working on GDPR and PCI compliance currently. The next step is going to be retention. So most logging providers on the cloud, there's a fixed amount of period on how long logs are live for. So when you send us a line of logs, how many days or weeks before that log line is deleted out of our system. So typically for LogDNA, we have a number of different packages. We have a standard 7-day retention, 14-day, and 30 days. But we can go longer if needed. So it really depends on what your needs are and what kind of auditing log levels you need for the future. We do have things like S3 archiving. So, like 30 days of retention is mainly for how long you can have to search your logs live. But some customers, they're like, hey, I'm good for the 7 days of live logs, and everything after that, you can just gzip onto an S3 bucket, and then I'm good from that point forward. And then the last two things are just mainly about how much volume data you're sending us. We found that depending on the company and how well structured their logs are, the volume is going to be what really determines your cost for most log management solutions. So if you're logging, for example, like a gig a month, it'll be really, really cheap. If you're logging like 10 terabytes a day, the numbers will definitely get up there. So it really depends on your traffic mainly and what type of logs and how verbose your logs are.
And there's kind of a balance to be maintained there, right? The more verbose the logs, the more useful they are. But of course, then you have to store them and then how long you want to store them. So it's about trying to figure out what level of logging you need to be effective and be able to identify issues, monitor things, and then go back and identify the root causes if needs be.
Yeah, absolutely. And of course, the last item is very much important to many CTOs and executive level staff. So one thing that we do just a little bit differently with LogDNA is that we don't have what I call bucket-based pricing, where you have, like for example, every month you get a bucket of 10 gigs or 50 gigs or 100 gigs or a terabyte. We are a metered billing provider, very much like AWS. If you use 1 gig, we charge you for 1 gig. If you use 2.34 gigs, we will charge you for 2.34 gigs. And so we found that actually with that, surprisingly, a lot of customers who have been holding backlogs because they're nearing their 1 terabyte bucket with their current provider, for example, when they come to us, they're like, okay, so our terabyte has stayed the same, but now we can loosen it to like 1.2 so that, and not have to worry that those extra logs are going to push them over to the next tier, essentially. All right. So I just want to go over very quickly just the different types of log management available. So LogDNA is the first one currently. We are a cloud logging solution. So basically, you send your data directly from your servers or from your IoT devices or from your apps directly to us in a cloud. And we have a number of different ways to take in logs, which I'll go into in a little bit. The second one is an on-prem provider. Basically, what this really means is that you can download and deploy a logging solution onto your own servers. So you manage these. They're typically, it doesn't have to be like on-prem as in like in your own data center necessarily. On-prem could be like on AWS private cloud or on GKE or any sort of thing. Basically, you control and manage the servers. And then something newer that's sort of come onto the landscape recently is multi-cloud. Now I'll get into a little bit about that. So it's basically a hybrid of both. You can have some of your logs stored by a cloud provider and some of your logs stored on your own servers. And then just through a single pane of glass, you can see which ones and search sort of all your different sources wherever they are. So this is really useful for situations where, say you have 5 data centers around the world or 5 offices, and each of them are logging separate types of logs. But when you do search, normally you had to go to each of those sites and then search that particular one. And then if that number grows, you're going to multiple places. So what multi-cloud does is that you can start search from one interface, and depending on your own level of access, you might be able to access things in Europe, for example, or things in Asia. And so multi-cloud unlocks basically some of those functionalities to let you be flexible, switching between your own sort of on-prem deployments versus a hybrid of on-prem and cloud deployments. And so this is one of those things that LogDNA is actually working on in the future, where we're hoping to be on-prem, which we are currently in beta for. We have a downloadable version of our product as well in private beta, and the multi-cloud will be the next item we're going to be tackling. And finally, I just want to mention there's a number of self-managed or self-hosted solutions out there. ELK is definitely one of the most popular ones. You can take a couple different components from Elastic and then be able to build your own Elastic Stack log management system. Just want to get through some, right off the bat, some best practices for Kubernetes logging specifically. There's many best practices of logging, but these are all specific to Kubernetes. Most of our customers, when they deploy with us, we recommend many of these. So the first one is, and I'll go through each of them in detail. The first one is basically, you should always separate your dev and production containers into multiple clusters. So don't have like one cluster that holds all of your containers and all of your apps. We've seen it just increases the level of risk. We've seen customers accidentally, delete a pod that was a production pod, not realizing it was, and not even realizing for a couple hours later. And then they're wondering why their skill is not as good. Things like that just gets avoided if you have multiple clusters. Kubernetes does a really great job of managing context and multiple clusters. And there's just, the federation is pretty good if you wanted to get into something like that. But
plus in terms of logging, alerts from dev, usually not a big deal. Alerts from prod, oh my gosh, everybody get out of bed. We need to get in there and do something about it. So definitely good advice in terms of on the logging front and on just keeping isolation of production.
Absolutely. So the second point is an interesting one. So config maps are basically like key value pairs inside Kubernetes. What we see a lot of companies do to separate multiple environments like dev and prod or staging and prod, for example, is they would take their app and they would copy and paste the YAML file and then call it the second one, that same app staging. There's a couple of problems with this. One is that it's hard to keep the pod specs in sync all the time. When you add new things to one, you got to remember to add new things to the other. We always recommend taking a more of an environment variable approach where you take all the environment variables out of the YAML file and you put it into a config map. And then you just have two sets of config map, one for production and one for staging, or one for dev or whatever. And then now you can have the same YAML file for that one app and always ever only be one. We found that this is just, it gives a lot more flexibility, it reduces errors, and it just much easier when you check all this stuff into Git, it's much easier to manage. The next one is kind of a no-brainer. Kubernetes by default for logging supports two streams. One is standard out, which goes into kubectl logs, and the other one is an error stream. So if you raise errors in your app into standard error, Kubernetes will automatically put that into the standard error stream. The next one is about using sidecars. So there are some valid use cases for sidecars. We just would always steer people away from it. It's better to just log everything to standard out. It's just easier. When you log to standard out, it's handled by the Kubernetes internal logging framework. When you use sidecars, it kind of scripts around that. You don't see your logs as kubectl logs. Or if you do, or the reason why most people use sidecars is because they don't want to expose the logs to the node level. And that's probably the security is probably the only real use case I can see that's good. Otherwise, what a sidecar is inside your pod spec, instead of having your main app as a container, you have your main app plus a second container that's just used for logging. It uses a lot of resources because now you're basically doing, instead of doing a log agent on a per node basis, you're doing on a per container basis, which makes it much heavier for everything. And of course, logging to standard out for all apps is what we always recommend. This is part of, I would feel, is the Dockerization process for most apps. When you Dockerize your apps, many apps, instead of logging to files on disk, which is very standard, but now you sort of just console log out directly to standard out, and then Kubernetes will handle that. So many companies we see that transition from like VMs to Kubernetes, this is one of those things that they've had to sort of retool on their app. But it's well worthwhile, and it gives you much more flexibility at the end of the day. And finally, we always recommend testing locally. There's a number of great tools for this. So Kubernetes offers something called Minikube. Minikube basically is a full copy of a Kubernetes cluster on your own laptop. It's maintained by Kubernetes and Google, so it's actually really nice. It gives you an idea of what to expect from your container when it's running on production without having to actually deploy there.
Yeah, and to add to that, we also recommend that you test ephemerally prior to deployment. And when we talk about ephemeral, what we mean is, can you create an environment right off the scratch? Let me start again. Can you create an environment for every pull request, for example, to test your entire stack in before you get to deployment? And one of the reasons that we recommend that is that there are some limitations on Minikube. It's great for local development, but you'll find that it doesn't perfectly approximate a production cluster. Whereas if you can stand something up automatically you know it's going to work because you started basically from scratch. And so you can do that. We actually have a lot of people who do this for every commit. They actually create an ephemeral environment, which will be pulled down afterwards. And this gets you out of the mindset of thinking that, oh, I have a special like staging place, which can then, you know, potentially become corrupted or something. And the chances of something working once it's deployed into production, if it's been deployed ephemerally beforehand, are very, very good. I mean, it's kind of the gold standard. So, and as before we move on to the next slide, just a quick reminder, as you have questions, feel free to use that Q&A button and add them in. We will be answering those questions at the end, and I can see that there are a number of questions already coming in. So good on everybody for doing that.
All right, so I just want to just touch up really quickly upon this. This is how Kubernetes by default handles logs without any configuration. So containers on Docker from the Docker daemon will automatically go into a JSON file on disk on the node. So on the node level inside var log, that's where all the container logs will live. If you do not set up any logging by default, those logs are gone when the pod is evicted or when the container is deleted. So when a container restarts, it will save a copy of the previous container's logs, but only for so long. And then when the pod is evicted, then those logs are gone forever. So this is one of the reasons why Kubernetes logging is so important, is literally because of this slide. We want to make sure that those logs are not gone, because if you send it to a third-party provider, or if you log it using some sort of internal Kubernetes, which I'll explain in a second, then those containers do not get lost.
Yeah, and just to add on to that, if you're in a situation where you get basically an image crashing all the time, actually, here's an example. I know a lot of people who actually are using Java containers, and they the way that they've figured out that's the most efficient way to handle garbage collection is to turn off garbage collection and let the container suicide. And it's actually kind of it's funny, right? But it's kind of a container first mentality of like, look, if I'm on Kubernetes, my container is going to restart faster than I can do garbage collection. It's cheaper to start a new container than to do garbage collection. Now that's a situation where Kubernetes is basically just going to be destroying logs consistently, and now, you know, if you do need to go back and find out about an issue or debug something, all of a sudden you've lost your history because those logs aren't going anywhere. And I mean, that's one situation, but there are just a ton of situations and scenarios where you end up with logs that have been dropped and you're looking at an incomplete picture. Plus, just getting logs out of var log for even a deleted container, it's actually a really big pain. So I don't really recommend it. It's like, if you have to do it, I'm sorry. You've made some terrible choices were made that brought you to this point, and I'm sorry for that happened. But that's the situation with Kubernetes logging today. And I think you were going to go a little bit into kind of some of the options of how we can fix that.
Absolutely. So what do most people use for logging, or how do we do logging so that those container logs are not lost? So on the left-hand side is what FluentD does, and on the right-hand side is what LogDNA does, and I'll explain each piece. So the FluentD method is the one that is on Google's docs. So they say, hey, this is how you can not lose a log, because they understand this is a problem. So it's the same as before. The logs go into var log. There's a FluentD agent, which you go create your own config and say, hey, here's what I want to do. I want to grab all logs and then push them into a Elasticsearch setup locally in my Kubernetes cluster. So you create a config, you set up all the different rules you want to do. You set up the output to Elasticsearch, and then you run the FluentD agent pod that will basically go on node level, collect all the logs, and then send it all to Elasticsearch. So, and then you stand up and then you sort of manage your own Elasticsearch cluster with Kibana and Elasticsearch and FluentD as a whole, as a set. So it definitely works. It works fairly well. Some of the problems that we've seen with this mainly is if you have low logging volume, it's not bad. Elasticsearch is is a little bit beefy, it requires a little bit more resources. But overall, you can get a fairly good logging solution just by doing this. But mainly if you start to have any sort of volume where your logs are no longer, or basically you have to manage Elasticsearch and scaling it, that is sort of where all the problems we've seen have come to play. Most people who sort of dive into Kubernetes don't realize that Elasticsearch is a completely different technology that's not made by Google, and this is something that the docs don't really make very clear. It makes it seem like this is part of what you do in Kubernetes, that Fluentd somehow is managed by Google. It's not. Fluentd is a completely separate company called Treasure Data, and Elasticsearch is a product from Elastic. So
you could also get in these situations where when you do the setup and you set up your matching rules, you may not have been as thorough with that as maybe you wish that you had been. And then you end up saying, hey, these logs are missing. Oh, well, it turns out it's a configuration in Fluentd. Who even set that up? We set it up one time a long time ago. We don't remember. So you kind of have to have a really solid plan together if you're going to go the Fluentd route.
Yeah, and that's trying to say it's impossible. Like it's just take some time. This is probably, if you already know each of these products and know how to configure them, and you know how to sort of manage the Elasticsearch and Kibana portions, I would say that the entire setup will probably take you about an hour to get everything up and running fairly quickly. Obviously, if you've done it before, it's a little bit faster, but the majority of the time effort is really spent on the management after you grow. So if you have larger traffic, it's going to quickly devolve into, okay, and I need to create more nodes. I need to create more master instances. I need to upscale my nodes. I need to have more disk. And so these are all the types of things that will sort of happen. So on our end, what LogDNA does differently, because we're a cloud logging provider, we don't need anything running on your cluster. So we don't take up resources. We don't need more servers or VMs or bare metal instances or whatever you're using. We don't need more of that. We just have an agent that sends data over the internet over to where we are. And so it simplifies it a great deal. And I'll show you our integration. So to get our agent installed, we looked at sort of like what Fluentd is doing and how to set up Elastic. And there are guides that help you do this. There's usually it's like a 30-step guide with screenshots. It's not bad. You sort of follow it, and then step at a time you set up each component in each piece and then linking them together. For us, one of the key benefits of LogDNA is we can get you logs up and running in 2 kubectl commands. And so literally the time it takes for logs to start flowing is about the time it takes for a container to spin up. So for the 2 commands are very simple. The first one is basically your key. So once you create a LogDNA account on our website, there's an ingestion key there. You copy and paste that into this command, and then it'll set up the key as a secret. And then the second command deploys a daemon set onto your Kubernetes cluster. And so what a daemon set is, for those that don't know, is it's a pod, same as a pod spec, except that the pod automatically gets scheduled onto every single node in your Kubernetes cluster. So if you have, say, 10 nodes in your Kubernetes cluster, there will be 10 LogDNA agents, because what we do is we read the var log folder on that node, and we take every container's logs from the node itself. So this is what Google recommends as an agent approach, is to do a node-based level logging is the most efficient, because all the files are already collected there by Kubernetes by default. And so this is a GitHub link. You can see what the YAML has. Basically, what we do is we monitor var log. It also works with Minikube. There's a couple different other mounts points in there that helps with that. But overall, what it does is it creates our Linux agent as a pod and runs it in your Kubernetes cluster. And a couple things we do automatically. So in Fluentd, in order to get things like the pod name, the container name, and the namespace and such, because Fluentd wasn't natively meant to do this, you need to run some sort of inline filters and in-stream processing to sort of enrich each of your log lines with this kind of metadata. We do it on the server side on our end, so we don't actually spend any CPU cycles on your cluster to do any of this stuff. We take it on our end, and we do things like parsing for JSON, Apache Nginx logs, Mongo. There's a whole bunch of common formats that we have on our docs. But basically, we take all the sort of the parsing and things like that out of the equation, so you don't have to manage those. And you don't have to sort of tell us ahead of time that this log is an Nginx log or anything. We auto-detect every single log line they send us. We run it through a number of different pattern matchers, and then we figure out what type of log it is. And then we start indexing all the pertinent items from there. Let's see. So I'm going to jump into I'm going to go ahead and start sharing my screen, and I'm going to jump into a very quick, we're hoping this to be about a 10-minute demo. Really fast just on how LogDNA works, and I can show you some of the UI elements that we have. And then we'll take this and sort of create this real world. So we've created this real world scenario of we've detected an issue, and we'll go through and show how we can debug that and issue a fix and get it updated. We can see your screen. Okay, awesome. So this is our demo account for LogDNA. I just wanted to show you some of the interface elements. I stopped live tail. Perfect. This basically is what a login looks like when you first log in. I will go ahead and show you some of the different ways we take logs in. So we take logs in through a number of different methods, not just Kubernetes, but the Kubernetes integration will be here, and the same two commands are there for you to see. We also take logs in from generic Linux Ubuntu and RPM-based Linux as well, and from various platforms like Heroku or Docker or FluentD, as well as from syslog. So you basically, to set many of these things up, we basically for every for agent, as always a good example, we try to keep everything so that you can copy and paste the entire set of commands. So at LogDNA, this is one of those things that we're really focused on, is minimizing the number of steps for you to install and onboard servers. It's very important to us because our belief is that the easier the onboarding process is, the more likely you'll actually be able to get all the sources that you want to have logs draining to us. We always recommend our agent by default because we think it's the most versatile. It's also the most battle tested. Many companies with like hundreds and thousands of log lines per second use our agent, and it's been well tuned for many use cases. Anyway, so back to the interface. So as you can see, there's a timestamp as the first part of the line, and then there's a whole bunch of items in orange. So orange items are basically sources, and they collect into a menu called all sources. So sources are, in this case, it could be pod names for Kubernetes. It could be host names for syslog or API-based servers or what have you. And one of the things I want to highlight is that we don't need you to ever maintain LogDNA. If we don't see a source for a while because you have a cron job on Kubernetes that creates new pod names every single time, things that we don't see for 3 days drop into inactive, things we don't see for 7 days drop off the list. Basically, there's no maintenance of LogDNA required. You just use this to get your logs, go back to work. That is our primary use case. For all the items in blue, those are container names in Kubernetes, or for syslog, they are app names, or if you're using a Linux agent, there'll be the path to the files that you're looking for. So if I go ahead and just sort of, for example, and just choose like my Nginx here, for example, this will basically, as you can imagine, it'll narrow down to just Nginx-based logs. One of the things I want to show you with Nginx specifically is the auto-parsing aspect. So if you open this little triangle at the beginning of every single line, that shows more line context of the line. So we automatically detected this was Nginx. We can see all the different variables on the line. We basically parse those out into individual fields. Now, why is this important? For numeric fields, for example, you can do range-based searches like greater than 200 but less than 300, things like that. Or you can graph, if there was a response time in your Nginx, you can say, what's my 95th percentile for response time? Is it like one second, or is it like 500 milliseconds? Things like that. We also grab all the sort of pertinent Kubernetes metadata, as I mentioned earlier. So things like pod, container, namespace, the node it's running on, and a Docker container ID, as well as any image or labels that you may have attached to your container. We grab and read all of those automatically. You don't have to tell us any of this stuff ahead of time. The 2 commands I showed you earlier is how you get all this information. And then for search, we also have a search box at the bottom. You can search for pretty much any word you see on the screen. So our search syntax is super simple. This is one of those areas that we really wanted to sort of shine. We did not create our own sort of query language that many other logging providers have done. We want to keep it as Google-like in syntax as possible. So by default, if you put a quote around a string, we will search the entire string together. If you just put words, they'll be ANDed by default. If you have an OR, it will OR between 2 items. The negative sign for something will exclude those lines. So very simple. The basic use cases are very simple. We also support very complex base matching with grouping of ands and ors. So you can sort of see our full search guide if you want to do more. But by default, you shouldn't have to get training or learn how to use LogDNA to get started. And so I'm going to search for something like the word curl here on the line. So if I search that, it will basically come back with only the items that have the word curl in it. So all the other items that don't have it will be gone. And if I can further refine this by putting something like website, what that does is it only brings back, imagine, things with a website on it. And if I go back into just a random line here, within the line, there's also a couple of items on the top. One of them is called view in context. So if you are familiar with grep-c, so that's what this does. So right now I had a filter of curl website, but this is what the original log looked like coming from Kubernetes, for example. We see that, the line immediately before it, if I didn't have any filters, was an error. Like these type of things are easily more surfaced when you have a view like this. And right now, as you can see, the pod name is the same because by default, we narrow by just this exact pod and this exact container. But let's just say you have Nginx replicated 2 times, for example. So you can also just narrow by container only, and now I can see both pods running from the same container running in 2 different pods replicated. This gives you a sort of a good bird's eye view. If you have a load balancer, a load balance app, now you can see sort of logs in context across all of them. And once you sort of have like a whole bunch of filters at the top and some search keywords down, you can also create a saved search. So saved searches we call them saved views. They're also used for alerting. So we can attach alerts to them so that if new lines that come in that match curl website or whatever the criteria is, you can send them to, for example, send them to Slack. And you can set thresholds like, only search more than 10 in a minute, then Slack me, otherwise just ignore it. We support a number of different output channels. We have a generic webhook, we have PagerDuty, and we're adding more things like Datadog and Librado into this in the future. But I'm just going to go ahead and create just a regular view called my view. So views by default show up in this in this list here, and so the view I just created is now under uncategorized. So you can create additional categories if you like, and then but all views are by default team shared. So everybody on your team that you invite see all the views that you've created, so you can share views very quickly amongst your team members. But we also have stars. So starred views are basically your own. You can have your own drag list order of your own starred views. Starred views are per user. We also have a jump to time feature. So internally, we also use Elasticsearch for our backend to store all the log lines. So we index per customer day by day. So what that really means is that we know where every time boundary is for every single day. So for example, even though, say today is April 5th, so let's say I want to jump back to 3:25 at 3 a.m., for example. Even though that 3:25 is many, many, many days away, instead of searching back one day at a time to get there, because we know where all the time boundaries are, we actually just circuit that by going straight to the 325 index, opening that, and then performing 2 searches, one starting at 3 a.m. and going forward, and the other one from 3 a.m. and going backwards in time. This gives us a lot of flexibility because let's say you're logging 10 terabytes a day. Normally to search through line by line for 10 terabytes a day will take some time. But if you have jump to time, you can now bypass many days and many terabytes and go straight to the logs that you're looking for. And so one of the key reasons why a lot of our larger customers choose us is because we don't run the plain vanilla version of Elasticsearch. We have our own custom fork that really does one thing. And I'm happy to explain this further if you'd like. But the gist of it is that Elasticsearch out of the box, they do what's called a table scan. They do like a wildcard search one line at a time. We do an index scan because we tokenize enough words and around symbols and capitalization that allows us to be really fast at searching. So Elasticsearch by default is around 5 gigs or so per second, maybe a little bit higher if you have a little bit faster disks. But our search speed is closer to like 100, 200 gigs per second, depending on the sparsity of your data.
Oh.
So we can search orders of magnitude faster than the default Elasticsearch. So our custom fork, it's really simple actually. It does really just that one thing to allow searching to be much faster. I want to show you also some graphs. So we also have graphing views to be able to visualize some of the data you have. So I'm going to start off just by showing all the log lines sort of that coming into your cluster. So this is without any filtering. So this is all log lines. You can also click on this little filter icon, and then you can filter down things like app is my Nginx, and then that will reduce the filter by that. But you can also do exactly anything you have on the search bar. Like one of the things we did earlier was the Kura website. So you can do that as well. And then now I can see, it's a very much more narrow set of results. And one of the beauty being us being both the sort of the metrics provider as well as the logging provider is that we don't just have the number 4 because we incremented a counter somewhere. We have every one of the 4 lines behind it. So if you click on the bar, you can actually see logs from that time frame, from that 10-minute window. And we can see that indeed there's 4 lines between 1240 and 1250. This is because we have every one of our bars is backed up by actual data. And when we do rollups like this, it's easier to see stuff like that. Let's see. If you have a numeric field, for example, let's do something like response. So if you have a numeric field, we allow a couple more things. So not only do we just allow counts like we do with text-based histogram-like fields, we also have things now like all your stuff you might expect, min-max average, as well as percentiles for more DevOps like metrics like response time or connection time or service time, things like that. Anyway, that was sort of just like a very quick overview of what we do. I wanted to show just one more thing, which is how we do parsing for JSON. If you send us JSON, which is what we always recommend, structured logging is something that we encourage many of our customers to do. You will be able to it'll build a tree like this. So any JSON you have, we will accept up to 3 nested levels deep, not just the root level. And we also accept up to 1,000 custom fields per day for JSON. So, send us the data, we will break it down, and numeric fields are automatically identified so that you can do all of the things with numbers I mentioned prior. And that's about it for the demo.
Great. So that is awesome from a overview of what we're going to look at. Now, from a real world perspective, what we're going to look at here, I'm sharing my screen now, is I've actually set up an alert and it's found an issue. And now how can I go and issue a change and get it deployed? And I'm actually going to use Codefresh to do this, but first let's look at the alert that I got. You can see here that I have this LogDNA alert. So if I open that up, it will tell me that it looks like an image is broken, And I can click right here, and this will take me straight into LogDNA, which I should have been logged into before this. All right. And I can see this is the alert that I set up to find broken images. And of course, if I expand this out, I can see the namespace this is in, the container, a lot of those things that Lee just pointed out. Now, I actually am familiar with this namespace and this application. I know that they're running right now. I have it running in a cluster. So I'm going to jump over to Codefresh to figure out what's going on there. So let me log in here. And I'm going to go over to my Kubernetes cluster. And you can see I've got a number of Kubernetes clusters connected here. I'm just filtering for the one that's relevant. And I can see this demo chat namespace. And I can see that everything is up and running. Okay, so I know that, you know, the service is there, the deployment, the replica set pods, all of my kind of infrastructure is present. Okay, so that's not the issue, which makes sense. I mean, if my pods were down, I wouldn't be getting a log telling me that there was a 404 error, unless it was pulling from I guess a separate service. So it could have been an infrastructure issue if I had a separate kind of container service here. So let's open up the app really quick. Now it told me that an image was broken, and I'm familiar with this app, and I know that right here there's supposed to be a big background image. So looks like that is broken right now. So if I click on, I can see the image that's currently running in production. If I click on that image, it's going to take me over to a report, and I'm going to see who pushed this. And spoiler alert, it was me. That's me, always breaking my own stuff. And I can see that this one did pass unit tests, and it does have kind of a security scan associated with it. So wouldn't expect a security issue to be there. Let's look at the commit and see what was changed. And I can see that, here is the issue. Somebody changed, well, not somebody, me. Because it says I committed it 4 hours ago. Somebody changed the link to the image and added this whoopsie URL. So I have a couple of options at this point. I've actually diagnosed the issue. Now let's say that I hadn't been able to diagnose the issue, and this was really just causing a service disruption. Well, I could actually roll back the change without knowing anything. So I could go over to my, in this case, I'm actually using Helm. I don't know how many people in the audience are familiar with Helm. It's a package manager for Kubernetes. And I can actually go and look at my releases here, and I can see my application demo chat. I can see that it recently issued a change this morning at 9:22. Shortly thereafter, I saw this error alert. And I could actually just go back and issue a rollback to the previous version of my application without even having diagnosed what was wrong. And this will restore me back to state, and then I can see if that is going to work or not. Now, in this case, I actually know what the issue is, so I'm just going to issue a fix and let it roll out normally because we weren't able to digest it and figure it out. Of course, I would be able to look at the diffs to see if anything in the chart had changed. So this gets you into kind of that GitOpsy kind of world where you're tracking infrastructure changes and things like that. But in this case, I already have identified the issue. So what I'm going to do is I'm going to issue a fix, and then I'll explain what's actually happening. So I'm going to open up the file in question. I can see that I've got my whoops text here. Don't know why I put that. That was a terrible idea. So I'm going to go ahead and commit that. Images. All right. Oh, push that. All right, so I'm going to push that change. Now this is going to kick off an automated pipeline. So this is actually a chance maybe to introduce what Codefresh is in this whole thing. So we did get to see that it does show me a lot of information about my Kubernetes services and what's going on there. But really, Codefresh is a platform designed to help deliver containers into production. So we do have pipelines to build, test, and deploy images, as well as Helm charts. We have image management built in, so you can actually store the images. You can use our built-in repository, or you can push out to an external repository. And then, of course, we have all this tooling to help you deploy to Kubernetes, manage your Helm releases, as well as support for ephemeral environments. And so one of the things we talked about earlier was, how can I release stuff into an ephemeral environment before and test it thoroughly before I deploy it into production? So that's something we can support. And I'm not going to show you that flow today because we wanted to keep it simplified around this kind of logging workflow. But let's go and just take a look at my build that's currently going on, and I'll explain a little bit about what it's going to do. So we can see that it's currently building, and basically what it's done is it's cloned. Well, let me back up. These pipelines actually run on top of Kubernetes, and so when it kicks off a build, it's going to kind of set up a one-off environment where it can clone the code, build the Docker image, run anything that it needs to do. And this pipeline is actually going to be really container native. So each step in this pipeline actually runs inside of its own container, and there's a single data volume that's attached so that you can pass information between steps. Now I can see here that my unit tests have passed. Now it turns out I should probably add a unit test to make sure that images don't have a whoopsie URL in them, or the images resolve or something like that. That might be an integration step. I could integrate maybe with Selenium and have a step to deploy this and check it. And here now it looks like it has deployed, and it's building a Helm package that I could save and add to my Helm repository if I'd like. So that's Codefresh in a nutshell. And I'll just show you what that pipeline looks like really quick. Now we do have a simple UI for setting up pipelines, but in this case I did use the Codefresh YAML to do that. So here you can see it's going to build my Docker image. Here you can see it's going to run the unit tests, and it has some steps to set that metadata that I showed you earlier. When we were looking at that image, we could see that it had passed unit tests and things like that. And then I have my deploy step. Now Codefresh has out-of-the-box steps for deploying to Helm as well as for deploying to Kubernetes. So I just use that to get it deployed. Now let's go back and look at the status here, and I can see my service here is up and running. It looks, I don't remember what the image name was, but let's look at the application and we'll see, yes, our images are back. So we detected this issue with our logging. We had an alert set up. I got the alert. I jumped in. I was able to identify very quickly what was going on. I was able to eliminate a lot of possibilities of why things were broken. I could have just issued a rollback. In this case, I decided to just do a commit and roll forward. Now, when you make the decision to roll back or not, anytime you do a rollback, you kind of go out of sync with what's inside of Git. And so if you can avoid doing a rollback, it's maybe ideal if you can just do a roll forward. However, it depends on what the issue is. And if you're dealing with a potential outage, it's like, hey, I don't care what's broken. Let's roll back. Let's dig into it. Let's fix it. And then we'll do a roll forward on the fix where we have identified the regression and taken care of it. But that's kind of in a nutshell how it works. And this gives you a sense of how these tools work together, and also how Kubernetes handles logging in the first place. So with that being said, I think we can jump over to the Q&A is the plan. And I can see that there are a number of questions in here already, and I'll just leave this slide up. Now, go ahead and use that Q&A button to ask questions. Preferably, that helps us keep track of them very easily. And then if you do have additional questions outside of that, of course, LogDNA is happy to talk. They have a contact link. And then at Codefresh, we like to schedule one-on-one demos and run people through kind of what's possible. And our goal really is to help you deliver containers that are higher quality and to deliver them faster. And that's what our platform was built for. So with that being said, let's jump into some of these questions. And I did see some very good ones. Kieran asked why sidecar logging is not advisable.
Right. So the sidecar logging mechanism is good for, I feel like, a couple of use cases. One of them being you need to write out to 2 different log files, or if you have a security concern of the logs being sort of harvested by the Kubernetes' centralized logging framework. Outside of those, it feels like there's many different ways to solve the same problem. For example, if you log to a file and not to stand it out, maybe that's not trivial for you, but generally I would say logging to standard out is the Docker best practice regardless. And it makes it so that when you want to add new apps into your Kubernetes cluster, you don't have to go and tack on a sidecar to every single app that you have, and then maintaining that sidecar throughout your infrastructure. It also takes up resources. For example, however the sidecar is doing its logging, maybe it's file deep, maybe it's something else. Now you're sort of forced to be able to have to deal with all the resources and scheduling out of memory and CPU for each one of those things. Those are the main reasons why I do not recommend having a sidecar to do logging.
Plus, it's just in the same pod as your application, and so you don't really have like an isolation from that service. I think you mentioned earlier there are some reasons why you might want to do it. Maybe you don't. Maybe there's certain logs that you want to keep out of kind of the general environment, but in general, you would avoid it.
Right. Like if your intention is like, hey, let's not log this no matter what, let's just make sure it just dies quietly or something like that. I don't know. I'm sure there's use cases like that would be useful, but other than that, it's a lot of management and it takes up actual server resources on your cluster.
Yeah, good answer. Now we did have we'll try to go through all these questions, and just a reminder, this is being recorded and we will share out afterwards a link so that you can rewatch the webinar as well as forward it on to colleagues, and of course you'll be able to access the slides. This is a tough question from Jim Fitzgerald. He says, if I've heard correctly, one thing our legal department worries about is discoverability. Specifically, can a court order LogDNA to divulge our logs without us being notified?
Right, so that's an interesting one. I'm actually not sure what the answer to this is. I need to check with our own legal counsel on this, but from how our security works on our end, yes, we do see a copy of your logs. As a policy, we don't access it. That's about it from our end. But from a encryption perspective, everything we do when you send log to us, unless you turn it off, it's encrypted by default. When we store it on our disk, it's encrypted. Even within our own VPC, we use encryption and firewalls between private IPs. So we take security fairly seriously. From a legal perspective, I'm not sure about this answer. Specifically, I'm pretty sure a court can make us divulge the logs, but I'm not entirely sure if we're allowed to notify you or not. So that's a part I'll need to get back to you on once I get further clarification from our own legal counsel.
Gotcha.
But we have not done this yet, and so I don't know anything about this.
Good. Tough question. There's a question from Facebook from Irving. He asks, have you guys worked on logs integration where the source is the event viewer from a Windows server?
Yes, so we actually have a pull request for this very item. So we already support Windows Event Viewer logging, but only from one provider, like application or system. The pull request basically allows us to capture both or multiple, or if you want security or some of the other level ones. But yes, so we will be able to pull from that using our Windows agent. So we have a Windows agent as well. It's the same code base as our Linux agent, just has some very specific Windows-based tooling.
Then this is a question for me. Ren asks, how does Codefresh integrate with Kubernetes and Helm from a security standpoint? So there are a couple of different answers to that. In terms of just integrating with a cluster that you have existing and you want to deploy to it, what you do, and I can actually, I could show you. Well, basically what you do is you create a Kubernetes user. Now that user can be an RBAC user, or it could be an admin user. So you can restrict it as much or as little as you like. And then you basically just add that user to the Codefresh interface. Now, once it's there, all the pipelines in your account will be able to push to that cluster. Now, in terms of controlling access to that cluster, we do have a couple of options, which if you want to go more in depth on that, I invite you to set up a one-on-one with us and we can go through kind of all the options there because it gets kind of granular. But the other option in terms of how we integrate with Helm is that as long as the user that we're using to access Kubernetes has access to Tiller, we'll be able to connect to Tiller and do what we need to do. Now, on the other side, if you maybe don't have Tiller, but you're using Helm just for the templating, you can still use some of the out-of-the-box steps to basically render and deploy those files, but those configuration files onto your Kubernetes cluster. The last way, and I'm sorry for taking such a verbose answer, for integrating on building, if you want Codefresh to run on your own Kubernetes cluster, we have two options. One, we can deploy an agent similar to the way that LogDNA does, where now we can run builds on your own cluster, and basically your code stays on your own infrastructure. Or the second option is Codefresh is also available as a Helm chart, so we can actually run that Helm chart on your own cluster, and then you can basically manage it yourself. So, whew, mouthful. We had another question for LogDNA. Does your logging solution depend on FluentD or FileBeat collecting logs on the nodes?
Right. So no, we don't. That's a short answer. We have our own Linux agent that we've built and have battle tested with many of our customers on Linux servers. We're using the same one for Kubernetes because it really does the same thing. The app itself is real simple. All it does is it tails your log files and sends them over to us in a secure way. That's about all it really does. But on top of that, we built many different features. For example, one of the things we wanted to do was have compression on upload, right? So that you're not spending more egress costs on compression. So we encrypt, we compress, we have really robust disconnection handling. So for example, if your agent gets disconnected from our servers, and that's going to be quite often because we do lots of code deploys on our end, which we restart ingesters, and then now your agent will disconnect. But during a disconnection, you don't actually lose any logs because we buffer them into memory. If the disconnection is longer than like 10 seconds, we will buffer onto disk so that there's no lost logs of any kind. And what this gives us is that we have good robust mechanisms to make sure that log data, let's say we deploy 10 times a day and you get disconnected 10 times, your log should not have to be lost just simply because we're doing a deployment. And so all the stuff, because we control sort of both ends of the pipeline, we control the agent that's sitting on your server as well as and our ingesters on our server, we're able to do a lot of these things like very, very nicely, simply so that you don't have to do a lot of work. You run the two commands, and they basically work well in tandem to make sure that your logs are getting to us in a secure way.
Yeah, and I was really impressed actually running that, getting prepared for the demo. I ran those two commands, and then I had the viewer open, and it was like, oh, it's streaming, sweet, it works. So very, very quick.
Yeah.
Rod asks, it looks like Google GKE automatically starts pods called FluentD GCP to send logs to their stack driver. If I use LogDNA, do I need to kill FluentD pods, which GKE has created?
You don't need to. So if you want to, you can run, to be honest, multiple logging solutions in tandem and in parallel and compare the two, right? But yeah, if you don't want it to take up server resources on your cluster, then you would need to kill them. But other than that, ours can run in tandem with any other logging solution or provider you have currently hooked up.
Yeah, and to go a little bit more in depth on GKE, if you edit your cluster, you have the option to check a box to enable or disable stack driver. So you don't need to go and kill pods. In fact, if you kill pods, it'll just restart them.
Got it.
Which is like Kubernetes doing what Kubernetes do, man.
Right.
So you can do that. And then as far as it affecting billing, I would double check with the GCP team, but I believe that the way they set up, they actually waive their master node management fee and all the resources associated with that until you hit a certain tier, and then it goes to like $100 a month or something. It's like kind of one of their differentiators is the way that they price the master node is like really aggressive.
From like free to like $100.
Yeah, but you're spending at that point you're spending like 15 grand a month on a cluster or something. You know what I mean? It's like it's the way it tiers up. So I would double check on it, but I'm pretty sure that you don't have to pay for that today. I think that the plan is probably to charge for Stackdriver at some point in the future. A lot of those beta features kind of work out that way.
Yeah, they actually did charge for it. They started charging for it a while back, and then they stopped, I think, after some people complained.
There's a little bit of a riot.
Like, I not paid.
Yeah, makes sense.
So that was that.
Another question we had, this one very specific to a Codefresh user, says, I'm using Codefresh Hybrid, where I'm running my Codefresh continuous integration pipeline on my own Kubernetes clusters using Docker and Docker. Will the logs from my Docker and Docker build steps, including the running ephemeral environments used in my composition build steps, be available to the LogDNA agent running on the underlying cluster? Great question. I'm not 100% positive, but I'm pretty sure that those logs don't end up on standard out today. So I don't believe that they would be available. I'd have to test it. Now for that, the way that we organize that, and I'll share my screen to show you what I mean. The way that, get rid of that. The way that works, now if you remember, I had this kind of view where I had jumped over to an image and there was an option to look at the logs. Now this is just isolated to the build logs. So I can see that it initialized, it cloned the repo, it built the Docker image, and it ran a deployment, and I can drill down on those, and it gives me kind of a basic, search and view. This isn't integrated today with any other external logging provider, and I'm almost positive that it doesn't log to standard out. So I think that's something that we should maybe do on the, potentially on the Codefresh side to make it easier to kind of support a logging solution like this. Now, what I would say is that where I think we really shine is that LogDNA can monitor all your production and help you debug there. And then Codefresh is really about helping you build and deploy. So we care less about we don't touch the logging of production or what's actually currently running, that kind of thing.
Right, and just to add on to that, I think the easiest way to check for something like that is just to run kubectl logs. If that can pick up the logs, so can we. So I would definitely give that a shot, or you can just try, we only have, it's only 2 commands, right? So give that a shot and see if anything comes in, right? When you run it, generally you'll see some like kube API stuff, DNS, like a whole bunch of different things, even if you have no other containers running. So some traffic will come in eventually. So give it a shot and see if it works.
We have time for probably 2 more questions, and then we'll go ahead and shut down here. This question from Irving, he asks, for an enterprise on-prem solution, our company would have to implement this through Kubernetes. Is that right? Or can I install it on a server? Now, on the Codefresh side, you don't have to, we can actually install an agent just on a node. It doesn't have to be Kubernetes. So we can actually take like an EC2 instance, for example, and use that as a node for Codefresh to build. And then on the LogDNA side, how does that work?
Right. So our on-prem product, which is not necessarily on-prem, it could be either on-prem or private cloud, is in private beta currently. And so how we deploy is also through Kubernetes. We typically deploy on our own cluster. So we have a separate cluster just for logging. So we have just like a number of different apps, a number of different microservices that it runs. So when there's some point like around 20 or so apps inside our framework. So that's how we deploy. It's basically a bunch of YAML files, and then we scaffold out. A lot of it is basically scaling Elasticsearch. We have a whole bunch of automated tooling that helps along with that, which is why Actually, our service, despite we're using Elasticsearch, actually takes less effort to manage than Elasticsearch overall. But primarily, yeah, we deploy to Kubernetes as well. We have not tried to sort of deploy ourselves onto an existing cluster. To be honest, I don't see why not. We are on a very later version of Kubernetes, so we do require version 1.9 or higher. So that may be probably more of a limiting factor than anything else, to be honest. Other than that, I know our stuff basically just runs in a Kubernetes cluster. We scaffold out, if you're at AWS, for example, a whole bunch of security and firewall rules and IAM access to lock that stuff down. Or on GKE, we use some of the built-in Google stuff. We don't have bare metal testing just yet, but that's one of the next things coming up in our private beta.
Got it. Great. So to close out here, thank you again. Well, we're going to answer one final question, and before we answer that, I just want to thank everybody for joining us. Thank you, Taryn, for putting this together. Thank you, Lee, for joining us, and really the whole LogDNA crew for supporting this. And again, replay will be sent to you. You'll get an email with that, and you can forward that to anybody else you'd like to see this, as well as the slides. Now, the final question was, can I start trying this stuff for free? And I'll let LogDNA go first.
Yep, so we have a free trial on our website. So it's a 14-day free trial, and it's a 1 terabyte free trial. So you can send us up your first terabyte absolutely free. We don't charge you for it. Beyond that, we have a number of pricing plans based on 7, 14, 30 days. If you're a very low volume logger, and we have tons of developers and hobbyists in our platform, if you log something like a gigabyte or 2 gigabytes, I think our lowest plan is something like $3 based on the minimum of the 7-day plan. I think it's like $3. Yeah. If you need a little bit more days, like 14 days, I think our price is, I think, $2 per gig for that. So yeah, our meter pricing is where we believe the future of the cloud logging is going to be. And so we're very happy we made the switch from, there's no bucket. So you don't have to commit to any sort of like 100 gigs.
Yeah, I didn't have to put in my credit card when I created an account. I actually challenge anybody that's here, the next time you're in a meeting, they say, hey, we need to figure out a logging solution. While they're talking, go to LogDNA, sign up, copy and paste the kube control commands and say, what do you think about this one? I just installed it. And then you'll get some heads turned. It'll be funny. And if you do that, please tweet at me because I'd love to share that story because it'd be really funny. And then on the Codefresh side, of course, we do have a free tier. We also do free enterprise POCs where if you're kind of want to do some of these more custom things, we'll do a 15-day POC with you. You just ping us on the website, go to the enterprise page and hit start POC, or on their homepage, if you scroll to the bottom, there's a start POC button. You can just create a free cloud account, and I think you can build, there are a bunch of free, you can do a bunch of free builds every month and try things out. So with that being said, thank you, everybody. We appreciate you coming, and we'll see you soon.
All right. Take care. Thank you.